Okay, I'll take a look at problem F5-10. Okay, so this is you're going to determine the support reactions at the smooth journal bearings A, B, and C. Okay, um, now because these are perfectly aligned uh, bearings, what we can say is there's no reactive moments. So that's the assumption we make with the multiple journal bearings. Okay, so what I did is I went through and I put in the reactions. Okay, now it's possible to have three reactive forces at each of these, so you could have nine. But since these are journal bearings, what you'll recognize here is that there's in the x direction, this can slide back and forth, so there's no reactive forces in the x or reactive force in the x direction there. You'll see that this one can slide back and forth here at B. So there's no reaction in the y direction. And the C one, you'll notice that it can slide back and forth along the x, just like the other one, just like A. And so there's no reaction in the x direction. So overall, you have the possibility of having six, you have, well, at this point, you have six unknown reactions that we need to take a look at uh, determining. Okay, I'll use the solution set as a base to talk about these. So first part of this, we can look at and find out what if we look here, what we recognize is that Bx is the only force. This one's in the z direction, negative z direction. Bx is the only force in the x direction. Okay, so we know that that one has to be zero. So we can sum all the forces, set them equal to zero, and really that's just saying Bx is equal to zero. Okay. The second part of this, what we could do is we can actually go about the origin here. If we look at the moments, right, and we could do moments about, we could find the moments about any of these axes, right? What we said is there are no moments about, um, no reactive moments about any of these any of these supports. But we can find the moments about different points. Now, what we'll do is we'll start with the origin here and look for to determine the moments about the z-axis at the origin. Okay, and you could pick either place. You could pick here or here or here or whatever. But if you pick here, then what you'll recognize is that in the z-axis, there's really only when you're saying it's about the z-axis, really all you have to do is look for um, forces and distances in the xy plane. Okay, so if we look at this from the A's perspective, you'll notice that the only forces really here that it can cause a moment about at this point are something over here and something over here, right? Because this component is going straight down. Well, what did we find about Bx already? Well, Bx was zero, so we know that's zero. So if we go all the way over here, then we have a Cy component, right? So the only forces we're looking at are forces in the xy plane. And what we'll notice, we have a Cy component here pushing off. We draw this line straight out, straight out, straight out. We see it intersects here at x, and now it's at a 90 degrees, a line 90 degrees from, intersects a line 90 degrees, at 90 degrees from um, the other line that intersects at the point at A. Okay? So when we do that, what we find is we're going to have this Cy, we could translate it right here, a force acting at this point, which is 1 meter from Z. And what you'll recognize from that is that, yeah, we wrote that moment. If you look for the other ones, Bx is 0 already. So we know that since Bx is 0, Cy is the only component, it's the only possible component to cause rotation about Z. So that one also has to be 0. Okay? So here's the moment equation, moment of Z, and this is at the origin. Uh, you have Cy, and here's the 1 meter, and of course that's going to be equal to 0. So now we know Bx is 0, Cy is 0. Okay? So the next thing we can do is we can look at the summation of the forces in the y direction. Okay? Well, we have Cy is already 0. We know that's 0. And Ay is the only other reaction that's possible there. So we can add these two together. Well, we know this one's 0. So if this is 0, AY has to be 0. Okay? So AY plus 0, this would be the CY. So that's 0. So that has to be 0. Okay? So now we have 3 of them. So we already knew 3 of them. We have 3 more. So we have just three reactions to find. Okay, the next thing we could do is think about, from a point. It really doesn't matter what point, but what we could do is just say, let's look for the moments about that would cause rotation about the x-axis, okay? The original one, even though I said point A or the origin, it really didn't matter. You could say anything along this axis, right? Because we were doing it as a plane. I just chose that point A. Okay, so we could choose any point here on the line and just think about it in terms of what kind of or actually think about it on the line, any point really doesn't matter. But we could think about what kind of rotations these forces will cause about the x-axis, okay? So first one is we have some component CZ at a distance 1.2, okay? The next thing we could do, we have this force acting down, and this is at a distance of 1.2 also. And we have this one's acting, this force is acting right on the line of x, so that one really doesn't matter. The next one we have is a BZ. So BZ is acting at from a 0.6 meters from this axis. Okay. So we have 3 of them, or potentially 3 different moments. So if we look at it and think about it, if we're taking looking at it from the side, and this is like our plane, the ZY plane, and we're looking at, straight down along that. Maybe this is the board, Z and Y make up the board. And this one's going straight up, so this one causes counterclockwise rotation. So we're going to get this moment due to this force is going to be positive. This one, due to this force at this distance, is going to be positive. And this one, from this distance to here, is going to be negative. Okay? So going back to the equation, and here are our CY, the CZ. This gives us a positive moment. The BZ is positive also because that would cause rotation about the x-axis in the counterclockwise direction. And the last one is due to the 450 Newton force, and that one is negative. Okay, so we sum all those together, and we come up with 1.2 ZZ, 0.6 BZ minus 540. Okay. Okay, so now we have 2 unknowns in this equation. So now we need one more equation to solve for that. So as I'm going through this, the way I'm taking a look at it and thinking about it is think about it in terms of like 2-dimensional problems, multiple 2-dimensional problems. Okay, so each time I say, like when I did it about the moment about the x-axis, I essentially said like I used the z and the y plane and kind of looked at it from the side. When you do the moment about the z-axis, you kind of look straight down at the top, looking down from above it and looking at it as a plane in the xy or an xy plane, okay? And then when we do it about moment about the y-axis, what we're going to do is look at it from the side, from over here, and look at it and see it as like the xz plane, okay? So multiple 2-dimensional problems because each time we're thinking about it, rotation about each of the individual axes. Okay. So the next one we're going to do is we're going to do the moment about y. Okay. So we're taking a look at it from the side, and we're going to look at it from moments about the y-axis, from the which would pass right through here. And if we look at it, we really don't have to care about these two. These don't have any impact on it. But we have a BZ going straight up, and we have a CZ going straight up, and then of course we have the same thing. We have this force going down. And here's the equation. So the same thing, except this time, if you look at it, what's going to cause? This one causes clockwise rotation. I'm sorry, this causes counterclockwise rotation, BZ and CZ. So I'm looking at it from this perspective, like I'm looking at it with just the XY plane. I see this one going up, which would cause, if you think about this as an axis, it would cause rotation about the Y axis in the clockwise direction, this one also, the CZ here, would cause rotation about the y-axis in the clockwise direction. And um, this 450 Newton is going to cause rotation about the y-axis in the counterclockwise rotation. Okay, counterclockwise rotation direction. Okay, so when we look at those, what we're going to see is we're going to have this one's negative, the BZ is negative, and this one's positive. So if we write that out, we have a negative CZ minus 0.6 BZ plus 270 equals 0. Okay, so now I have my two equations, um, two unknowns, and uh, we can use that to actually go and solve for these individual ones, right? So here's my two equations, my two unknowns I can now solve for. So here's one equation right here. Here's my other equation. And I can use these two with simultaneous equations and go and solve for, CZ and BZ. Okay. All right. So that leaves us just with one left, one unknown reaction left, and that is going to be the AZ. Okay. So AZ is going up, BZ is going up, CZ is going up, and this 450 is going down. Okay, so AZ plus BZ plus CZ is going to give you, is equal to 450 newtons down. And that's the equation. Okay, here's my 450, here's my 1350, here's my negative 1800. Recognize that this one is negative, right? So I just substitute in directly because what happened? I drew BZ as going positive, going up. Reality is it's negative. Okay, it's really going down. So if you just left it in that positive form like I did, I just said BZ, AZ plus BZ plus CZ, then I just substituted directly in. Okay, so here's my BZ, and of course this one was going down, so it's negative 450, and you solve for it, and you come up with 900 newtons. Okay, so the way to think about this one is, even though first I said about a point, really you can think about it in terms of a plane, right? So when you're doing the moments about z, I did up here, set it equal to 0. I was really just thinking about it. You could think about it as a point. And really, we were looking at like the origin each time, although we were really doing it about individual axes at the origin. Okay. So the first one was just using the XY plane. Okay, so it's like you do the moment about Z, you got XY plane. You do the moment about Y, you got the ZX plane. You do the moment about X, you have the ZY plane. Okay, and that's pretty much it.